Hi everyone, in the next part of this investigation we look at evaluating f of negative x for x is equal to minus 4, negative 2, 0, 2, and 4. So let's go ahead and do that. Well, just like in the last video, let's start by making a table of values. Because then we can use our table of values, our coordinates, to graph f of minus x. So let's see, when x is minus, we've got x is minus 4, minus 2, 0, 2, and 4 that we're supposed to evaluate. And when I plug negative 4 in for x in f of minus x, well, that's the same thing as evaluating. So f of minus, bracket minus 4, well, that's the same thing as evaluating f of 4. F of 4 from the graph is equal to minus 2. So when you have when you evaluate f of minus 4, you get f of 4, which is minus 2. Evaluating f of minus 2, well, that's the same thing as evaluating f of 2. F of 2 is equal to, let's see here, this is f of x, this black line, and we get that f of 2 is just 1. So you kind of get that, you can kind of see what's happening here. When we evaluate f of minus x, we're essentially evaluating f of x at the opposite sign. Like, so if you were to evaluate f of negative x at negative 4, that's the same thing as evaluating f of 4. Evaluating f of minus x at negative 2, that's the same thing as evaluating f of 2. We can do the same thing for, okay, so for 0, we're going to do f of minus 0, which is equal to f of 0. And f of 0 on our graph is just positive 3. Next, we're going to evaluate f of minus 2, f of minus x at x is equal to minus 2, or 2 rather. So that's the same thing as evaluating f of x at negative 2. Which is 0. And when you evaluate f of minus x at x is equal to 4, well, that's the same thing as evaluating f of minus 4, which is positive 4. So let's go ahead and we'll graph all these coordinates. So the first point that we're going to graph is negative 4 comma minus 2, which is here. And then we have negative 2 comma 1, negative 2 comma 1 is here. And then we have 0 comma 3, which is this point. And then we have 2 comma 0. 2 comma 0 is right here. And 4 comma 4, which is, let's see, 4 comma 4 is up here. So let's go ahead now, we can connect all these points. And this is the graph of f of minus x. So this is the graph of f of minus x. And the next part of the investigation, it says, let me scroll down. How do the graphs from A, B, and C compare to the graphs of f of x? So there's a couple really important things that we should note here. I should have wrote that this f of 0 is 3 here. There's a couple of really important things that we should note by looking at the graphs. Well, how does the graph of f of 2x, how does that graph relate to the graph of f of x? Notice that in the last video we talked about, or in one of the last videos, we talked about how the graph kind of looks like we've taken f of x and we've squished it horizontally a little bit. That's called a horizontal compression. And how much did we compress it by? We compressed it by a factor of 1/2. Okay, the distance between the y-axis and f of x has been, reduced by a factor of 1/2. If you look at how f of x over 2 relates to the graph of f of x, well, it looks like we've taken the graph of f of x and we've stretched it. And how much did we stretch it by? Well, what's the distance between this point in the y-axis? I have a distance of 4 units. I have an additional 4 units between f of x over 2 and the y-axis as well. So this, when we do f of x, when we evaluate, or sorry, when we graph rather, f of x over 2, notice that we get a horizontal stretch by a factor of 2. And then let's look at f of negative x. How does f of negative x relate to the graph of f of x? Well, notice that the graph has exactly the same size and shape, except for it's a reflection about the y-axis. So it's as if I've taken this, the graph of f of x, and I've flipped it 180, I've like essentially rotated it 180 degrees about the y-axis. So this is when you do f of negative x, that's a reflection about the y-axis of f of x. So let's write that down and let's summarize that. So, whoops, I need a different color. Okay, so f of 2x is a, whoops, f of 2x is a horizontal compression by a factor of 1/2 of f of x. Or it's a horizontal compression of, we should say it's a horizontal compression of f of x, I guess. Let's say that. So it's a horizontal compression of f of x, and then we'll say by a factor of 1/2. Let's write this down here. By a factor of 1/2. Next, let's write, let's summarize what we found about f of x over 2. F of x over 2, we found that its graph is a horizontal stretch of f of x, of f of x by a factor of 2. That is, we've stretched it horizontally by a factor of 2. And f of minus x, we saw, is a reflection. Let's say reflection of f of x about the y-axis. So we're reflecting f of x about the y-axis when we graph f of minus x. So that concludes this investigation, and in the next video we're going to look at how to apply these different transformations that I've discovered to a bunch of different parent functions. So how we can graph very complicated looking functions by applying these transformations to the parent function.